Hello everyone, welcome to my channel. I am still looking at integration, and in this one I have a definite integral. We are to work on the integral from 1 up to 2 of 2 to the power x minus 1 dx. Now this is an exponential function. How do we handle this? Well, we have to apply what we call the idea of natural logs. So here is the approach. Let me capture the integral. So we have the integral from 1 up to 2 of 2 to the power x minus 1 dx. What I was saying is we're going to let u be equal to 2 to the power x minus 1. What do we do next? Take natural log on both sides. That implies the natural log of u is equal to the natural log of 2 to the power x minus 1. Applying laws of logs, the power must multiply. So what we have now is the natural log of u is equal to the power x minus 1 must multiply by the natural log of 2. The power must multiply. At this point, I'm going to have to distribute there as follows. So what we have is the natural log of u is equal to x times the natural log of 2 minus the natural log of 2. Now at this point, we have to differentiate both sides with respect to x. On the left hand side, we have to use chain rule there. Remember, we have u, and also taking into account the idea behind differentiation of logs. So derivative with respect to x of this expression is going to be reciprocate the expression 1 over u times derivative of u. So times du dx is equal to, over here, remember the natural log of 2 is a constant, derivative of x is 1. So we just have 1 times the natural log of 2, so we have natural log of 2. Derivative of minus natural log of 2 is 0 because that's a constant. At this point, I have to multiply by the x both sides. So what do I have? What I have now is 1 over u du is equal to natural log of 2 dx. Fantastic. Now I'm going to have to multiply by u both sides on our next page. So page 2. What are we saying? We're saying we move this one down, and let me put these pages nicely together. So what I'm saying now is we have to multiply both sides by u. What we get is du on the left. On the right, we have natural log of 2 times u times dx. But what is u? Well, u is, if you look up here, u is just 2 to the power x minus 1. So I'm going to have to replace it with 2 to the power x minus 1. So what we have now is du is equal to natural log of 2 times 2 to the power x minus 1 dx. Now we have to divide by natural log of 2 both sides. We have du all over natural log of 2 is equal to the power x minus 1 dx. Nice. This expression here is this expression here, there. So that expression must be replaced by du over natural log of 2. But now we have to change the limits of integration, because remember, these limits here are with respect to x. So we have to change the limits to limits with respect to u. And we are going to use this equation here. So changing limits of integration, we're going to use u is equal to 2 to the power x minus 1. And we're going to say as x approaches 1, the lower limit, as x approaches 1, what does u approach? U must approach, we're here now, 2 power 1 minus 1. Remember, we have to replace this x with 1. And 2 to the power 1 minus 1, this is 2 to the power 0. What is 2 to the power 0? 1. So the lower limit doesn't change. Let's check if the upper limit changes. And as x approaches 2, which is the upper limit, as x approaches 2, as you can see here, What does y approach? We're coming back here, we're substituting 2 there. What does u approach? Not y. So u must approach to the power 2 minus 1, and the answer is 2 to the power 1, and what is it? 2. So limits of integration actually do not change. And therefore we can say, let me take this to page 3. Therefore we can say, therefore the integral from 1 up to 2 of 2 to the power x minus 1 dx must change to the integral from 1 up to 2. Remember, the limits of integration do not change, lower limit, upper limit. But where I see 2 to the power x minus 1 dx, I must have it replaced by this expression, as you can see there. So this is the same as du over natural log of 2. And remember, natural log of 2 is a constant, so I can take it out, and it's dividing. So 1 over natural log of 2 times the integral of 1 du, basically. So where is the 1 coming from? Where 1 times 1 is 1. It doesn't change anything. So we are taking limits from 1 up to 2. Integrating 1 with respect to u, you agree with me that this is just, outside we have 1 over natural log of 2 times u to the power 0, u power 1, obviously. You'll understand how that one works. I've explained it before. Maybe I need to explain that again. So we're saying the integral of 1 with respect to u. This is the same as integral of u power 0, assuming u is not equal to 0, du. What do we say? We say add 1, and then take that, divide. And what is this? U power 1 over 1, which is just what? U. And that's what you see there. Limits of integration from 1 up to 2, as you can see. So this is going to be 1 over natural log of 2, open brackets. We have to have 2 minus 1. Put 2 there and put 1, subtract. And you agree with me that this is just 1 over natural log of 2. Because that's 1. 1 times 1 over natural log of 2. This remains our solution. Because that's 1 times that, it will be that one. So that is our final solution to this integral here. I hope you found this useful. Your feedback remains very critical because it helps us plan on how we are supposed to present information on this channel in order to support as many students as we possibly can. I'll see you in the next one.